So we discussed the alkyl halides. So you know that we discussed that they are basically the halogenated ones, right? They are the where you have the halocarbons, the alkyl halides, right? We discussed that last time, and the halogen groups are named as the substituents, right? So the Iupac name base for the halocarbons are based on what is the parent chain, and then these are used as a substitute. They are the substituents. The halogens are the substituents here. Okay, so that's how you will name them accordingly, right? Like a chloromethane. If you have a methyl group, chloroethane, that's how you will name them. So we'll discuss today the alcohols and the phenols very quickly. And identifying an alcohol is a very easy, because the moment you will see a compound, if you see an OH group, you know that it is an organic compound with the alcohol as a functional group. And you know that, let me grab my pen. And you know that alcohols have the formula of ROH, isn't it? So R, and then you have an O, and then you have an H over here, right? That is a kind of a general formula for the alcohols. So alcohols and ethers are basically two classes of the oxygen containing compounds. After alcohols, we'll discuss the ethers. They also contain the oxygen. Okay. And alcohols, if you see here, how do we differentiate between first degree, second degree, and third degree, the primary, secondary, and tertiary alcohols? We know that if we have only one R group attached to the COH, look at this here, we have only one group attached, right? So what will we call this? We call this as a primary alcohol, right? So if we have two R's attached over here, let's say we have two R's over here, okay, and let's say this is CH over here, so this becomes what? Your secondary alcohol, okay. And let's say if we have three R's attached over here, then if this is C over here, then this becomes your tertiary alcohol, right? So now alcohols nowadays, we all are, because of the coronavirus, that alcohol, like everybody nowadays is using a hand sanitizer. I mean, even if there's an illiterate person in the house who doesn't know anything about chemistry, that person can also tell us that which compound is present in the hand sanitizer. Can anyone tell me? Hand sanitizers or the alcohol sprays which we use, what kind of alcohol do we have in that? Like, I mean, everybody knows that. hmm it is not ethanol. It could be ethanol as well, but what is the main one? hmm Have you ever read your hand sanitizers? Isopropyl, absolutely. Absolutely. It is the isopropyl alcohol, or we also call it a 2-propanol, right? It's the isopropyl alcohol. You are correct. It's not methanol at all. Of course not. It could be either ethanol. Usually when we say rubbing alcohol, right? Whenever you might have seen that if you're going for an injection, right? The nurse, she cleans the area where she has to inject. So we call it a rubbing alcohol. Rubbing alcohol is an antiseptic which contains which could be isopropyl alcohol as well as the ethanol. Okay, but the hand sanitizer, if you would have seen hand sanitizers, they contain the isopropanol, right? Or we also call it the 2-propanol. Okay, and nowadays if you say in Iupac name of, nowadays we don't even call it 2-propanol, we call it propane 2-all, right? So this is the compound which is present in our hand sanitizers, right? So basically, ethanol and 2-propanols are very important, because as I said that we call them together, we call them rubbing alcohols. They're used to disinfect the skin, right? As I just now told you that before the injections, okay? But do you know what exactly alcohol is doing to the microorganisms? Let's say, what does it do to the coronavirus? Question to everybody. Anybody can answer. check the chat. Kills it. Absolutely. But how does it kill? That's my question. I know that it kills it, but how does it kill? That's my question. What is the mechanism? Let me check the chat. Destroys. Denaturation of what? I know denatures, that you're right, but what is the mechanism? Absolutely. Destruction, denaturation, dehydration of what? Very good, Tanya. Dehydration of what? Disinfects. How? That's my question, guys. I know that it disinfects, it dehydrates, it kills. You all are using the synonyms of the same thing. No, it's not denaturation of fats. For the viruses, it causes the denaturation of the proteins. The proteins are precipitated because of the alcohol, right? So that is the antimicrobial properties of it, basically. Okay, but if we talk about the as an antiseptic, it can destroy the bacteria as well. It disrupts the cell wall of the bacteria. So that is why your sanitizers, your alcohol sprays, they're not only effective against the bacteria, they're also effective against the antiviruses as well. And especially they are more, effective against the influenza viruses, which are the coated, the enveloped viruses like our coronavirus, right? So that is how it is. That's how they are very, very important. Okay. So now, like, not talking about the Iupac names, okay, as you can see here, the we use both common names, and we are not more interested towards the common names. We'll just do the Iupac names here, okay. So you know that if we have to name a particular alcohol, we'll simply drop the ene, okay, e ending of the parent hydrocarbon, and we will add ol, right? So that's how you would recognize your alcohols, right? It will be OL at the end, like butanol, hexanol, propanol, butanol, right? So that's how you can actually, name them. Okay. So if you see here, look at this. We have started numbering. This is the parent chain, so it becomes 1, 2, 3 butane. If you have multiple OH groups, so you'll use as a triol, right? So here again, if you see here, we'll give preference to the OH group. And so that's why we'll start numbering from here. So this will become automatically 4-methyl 1 pentanol or 4-methyl pent 1 all, right? You will give the number also where the functional group is present. Okay. Let me give you one compound. Let me see if you can name this. I'll give you the easy one. If this is like this, who will name this? Question is for everybody. Who is going to name this? Participation in the class is important. Fatma says it's butanol. Okay, think once again. Mohammad Al Said, yes, please go ahead. You want to write or you can switch on your mic?
Yeah,
Yes, please go
it's
ahead.
the propanol.
Mm-hmm. Think again.
Oh, okay, I guess it now.
Two,
So
somebody said
methano,
2-methyl propane 3 all. How come 3 all, Tashil? You're very close. Okay, you correct. It's 2 all. Absolutely. Very good, Tashil. Thank you. Absolutely. Absolutely. Guys, why did you say that? See, you'll start numbering it from here. So what does it become? What will it become? Right? So it will be 2-methyl 2-propanol, right? So let me give you another one. No, no, no. I think I had, yeah, okay, I have it here. Who will name this one? IUPAC name of this one. Let me see. A. 3 propyl 2 heptanol. Okay, 3 propyl, two partners raise their hands. Okay, anyways, they've named it. Yes, it's 3 propyl 2 heptanol. How will you start your numbering? You'll start your numbering from here, right? So this is the closest, right? So that's how you'll start your numbering. That's absolutely. Who will who will who will answer the second one? This one, B1. Yes, somebody has raised the hand. Please switch on your mics.
Hello.
Yes, please go ahead. Yeah, the second one.
It's 1, 2, 3, 4. It's 5-methyl
Mm,
3-hexanol.
okay, absolutely. Very good. Thank you. Who was that?
موفق الغامدي.
Thank you, Mr. Gandhi. Thank you.
You're
Very good,
welcome.
guys. Okay, absolutely. 5-methyl 3-hexanol. So how will you start numbering it? You will start numbering because OH group is very close from here, right? So 1, 2, 3, 4, 5, right? 6. So it will be 5-methyl 3-hexanol. Very good. Absolutely fine. Good. So we move on to the ethers now. Or do you want to do one more or it should be okay? We'll not finish it. Then I think we'll move ahead with the ethers. Okay. So tell me about ethers. What do you know? What is, okay, being a medical student, there's something special about the ethers before we start discussing the functional group about the ethers. Where do we use ethers and what is so special about the ethers, guys? That's my question. The way we spoke about, sanitizers and the alcohols, what do we know about the ethers?
We can use it in the perfume or aftershave.
Uh, your voice is kind of breaking. No, my question is about medicine. Where do we use in the medicine? What is the use of ether in medicine?
Maybe anesthesia.
No, fruity smell. No, 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 no. That's not ether. I'm sorry, your voice is a little slow. Yes, please go ahead.
Stereo,
Sorry.
stereo.
No, 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 no. It has a very, very, it used to be anesthesia. Absolutely. Thank you, Faiza. Thank you, Lean. Anesthesia. Absolutely. In a while, I will share you the story of the, ethers. Okay. They have a very important story in the medicine. Okay. Ether, as we know, again, an organic compound which contains oxygen bonded to your two carbon atoms. This is the oxygen bonded to two carbon atoms, right? And the most common ether, which everybody knows about, is the diethyl ether, which is a very, very common ether, right? Even though diethyl ether is not the Iupac name of it, because in ethers, chemists mostly use their common names, right? So the diethyl ether is like everybody knows about the diethyl ether, right? It kind of looks like this, right? As it's shown over here, right? So this is the diethyl ether, and diethyl ether is very, very important. It has a very important role to play in the history of the medicine. Okay, as somebody rightly said that ethers were used as the anesthesia. That was absolutely correct, right? So ether was the first inhalation anesthesia which was used in surgery, right? And trust me, you cannot believe ether was used till your 20th century. Even I think, it was up to 1960 ether was used. The ether was, people stopped using ether, doctors stopped using ether till 1960. I'll tell you the history, how did it start basically. Uh, Ether was basically used in 1846. There was a very, very important doctor, and I think everybody would have heard about his name. It was Dr. Morton, Dr. William Morton, right? He was the one who first time used the ether to induce a particular a person, right? He was going for a dental surgery, something like that, right? So before that, whenever doctors had to operate upon the patients, they either used to not operate, uh, they used to delay the operations, right? So the surgeries which were really important, only those surgeries were used to be they used to do only those surgeries. And trust me, patients used to be awake. Can you believe that? For any amputation, arm amputation, can you believe the patients used to be awake? Or they used to tie their legs and arms, which you might have seen in the movies as well. And then they used to operate upon those patients, right? But then what happened? It was first in 1846, the first time the ether was used as an anesthetic. Okay, and then what happened? Soon after, almost 5-6 years later, than it almost in 1860 or 1859, something like that. What happened? We had the Queen Victoria of England. She used chloroform for her eighth or ninth, I think it was her eighth or ninth, she gave birth to her eighth or ninth child, and that time she used the chloroform. Okay, you might have heard about chloroform as well. The trichloromethane is the chloroform, right? So what she did when she used in almost 1858 or something like that, that was after the ether was being used. So it was like, Queen Victoria used the chloroform. So you know that how it happened, it becomes a word of mouth, and then everybody started using chloroform, right? So then kind of uh, because she used it, so it became very, very popular. So then what happened? Ether as well as a chloroform were used for so many years, trust me. Entire 20th century, they used chloroform and the ether, right? But then soon they discontinued the use of chloroform because it interfered with the people used to get cardiac problems, right, because of the chloroform. A lot of heart failures used to happen because of the chloroform, especially wrong dosage. And it in a high level of expertise was required to administer chloroform for patients, right? So that's why chloroform was discontinued, right? But why was ether discontinued, right? Even though both these things were used on patients, why did they discontinue using diethyl ether? The reason for that is basically, once they used to give ether to patients, ether, number one, is highly inflammable, right? That was one of the biggest drawback of ether, right? And second thing, when patients used to when the surgery, when they used to wake up from the surgery, what used to happen, they used to get constant coughing. It basically interferes with the mucous membrane, right? So they used to get constant coughing, nausea, and vomiting, right? And usually most of the patients develop a lot of allergies because of the ethers, right? So that is why, because of its unpleasant smell, and especially because it was very much inflammable. So that is why, and the recovery was very, very slow when they used ether. So that is why they stopped using ether, right? And nowadays, does anyone know what do we use nowadays as an anesthetic agent? I wonder if we will ever look at our modern medical practice in the future and think the same. It really proves how science and medicine evolve. Absolutely, science has evolved like anything, especially medicine. Oh my God. Yeah, that is my question, Yara. What do they use nowadays? Just in case if anybody knows about that. Nowadays, basically, they use a kind of ether. We call them isoflurane, right? Isosevoflurane. They are basically, fluorinated ethers, right? And that is like a common practice nowadays. So you might have heard about, there were many other things which were used. Nitrous oxide was also used, which is called the laughing gas, right? But nowadays, isoflurane is like the most potent one, right? Which is basically, at a very, very less quantity, right? It can anesthesia, it can use as an anesthesia. So they use it constantly. That was about the history of the anesthesia. Do you know how does it work, how anesthesia works, why you become unconscious? That's a local anesthesia, Yomna. That's a local one. We're talking about the general anesthesia, where you make your patients totally unconscious and they're not aware of what is happening with them. Yeah. Does anyone know what is the mechanism? It prevents brain from processing pain. Okay. How? That is my question. How? See, I'm trying to bring, PHSF in biochemistry, so that things become a little interesting. I think it blocks certain receptors. Okay, very good. I can accept that. Very good.
It interrupts nerve signals to your brain.
Absolutely. To be honest enough, we are not actually very sure, even though you know that how important anesthesia is, and like all the surgeries are being done using the anesthesia, but we don't have actually the real mechanism behind that. We basically have, the real mechanism is like these agents are very soluble in oil, especially like olive oil, right? So one mechanism, there are many theories. I will not go into all those theories, but the most acceptable one is that it says that, since they are dissolved, so since they readily dissolve in oil, especially the olive oil, right? So what scientists believe that they think that uh, these anesthetic agents, they also dissolve in our fatty membrane. If you remember last semester, we spoke about myelin sheath covering the nerve cells, right? So they say that when we give anesthesia to a particular patient, what happens? These anesthetic agents, they dissolve in the myelin sheath. As they dissolve in the myelin sheath, it decreases the fluidity and the shape of the membrane, shape of the myelin sheath. So as the shape of the myelin sheath is changed, or you can say decreased, or you can say, changed basically, right? So what happens? If you remember last semester, we spoke about depolarization. We spoke about how important is when the depolarization has to take place, it is very important that sodium should travel within the cell, right? So what happens when the shape of the membrane is changed, when the fluidity of the myelin sheath is increased, what happens? The sodium is not able to pass into the nerve cell. So rest you can easily expect. When sodium does not pass into the nerve cell, what should happen? Remember last semester? This is a plasma membrane. Inside it is negative, and outside it is positive. The nerve cell gets depolarized only when sodium travels where? Into the cell, right? So if the fluidity of the membrane changes, the mechanism says that it interferes with the sodium being, sodium is not able to transport into the cell. When sodium is not transported into the cell, what can you expect? Will depolarizations take place? Can we expect depolarization without sodium? Ladies, hello? Can you all hear me? No. Okay, great. I thought I'm disconnected. Yes. So when sodium does not travel inside the cell, so no depolarizations. As a result of that, the nerve impulse is not able to transmit through the cell. That is basically a proposed mechanism, right? So as it decreases the ability of the sodium ions, as a result, it blocks the nerve impulses. And that is why patients not able to feel what exactly is happening with them. Okay, so that was about that was about the diethyl ether. Okay. Okay. Now talking about the nomenclature of the ether, right? The Iupac names of the ether, right? Uh, Once, if we have, the oxygen, okay, along with the group, right? For example, we have methyl with the oxygen, right? So it becomes basically alkoxy. So we call it a methoxy. This will become ethoxy. Okay. So that is, if you see here, the Iupac name of diethyl ether is actually ethoxyethane. Okay. Just because it has an ethyl group, and along with that, it has the oxygen. So it becomes the ethoxyethane. Okay. So here, if you see here, so this is the, as I said that, you don't have to worry about the IUPAC names of them, but of these compounds, but still, if you know it, that's really good. Okay. So if I give you a compound like this, what do you think it will be? So it has oxygen along with the alkyl group. So I told you along with the alkyl group, it will become alkoxy. So what will this be? What is the name of this compound? Can anyone try this? Yes, Yara, please go ahead. Somehow I'm not able to see the chat window. Yes, Yara, please go ahead. How come it's not benzene? Do you think it's benzene? If you remember, I told you yesterday, you all get confused with the benzene and the cyclic molecules. It's a cyclohexane there. Nobody knows the name of this? It's a cyclohexane. Absolutely, methoxycyclohexane. Absolutely, methoxycyclohexane, isn't it? So this group becomes methoxy, right? So this is a methoxycyclohexane. Absolutely. So that was about it. Okay. Any other question about it? Amines. Okay. So what are amines, ladies? Let me move this slide first. Okay, tell me a biomolecule where you can find amines. Proteins, absolute. Okay, tell me a hormone which is okay, we're talking about endocrine system nowadays. So tell me a hormone which has an amino group.
Epinephrine.
Absolutely, dopamine, epinephrine, absolutely. We discussed that day before yesterday. Absolutely, very good. Absolutely, very good. Yes. So amines are very easy. They all have the amino group, right? They are derivatives of the ammonia. Okay. So this is a general formula of the amines. Like they will have RNH2 or they can have R2NH or R3N, right? So they can be a primary, secondary, or the tertiary amines, right? So basically amine is an organic compound in which the nitrogen, which you can see here, is bonded to the carbon atom. As you can see here, nitrogen is bonded to the carbon atom. Okay, so substituent here is the NH2 or NH, right? So if you see here, why this is primary amine, as you can easily make out, because here, if you see here, it's joined to R here. So this becomes your RNH2, right? So here we have, what do we have here? Here we have R and another R, right? So this becomes your secondary amine, right? So this is your dimethylamine over here, right? This becomes your methylamine over here, okay? And this is your trimethylamine, okay? These are the tertiary amines, okay? And when we talk about the Iupac naming, we know that we have to change the name E. Okay, we drop the name E and replace it by the amine. That's how we name the amines. Okay, so as you can see here, this is the 2-propanamine, right? Cyclohexamine, right? So we drop the E word over here and replace it with the amine. Okay, so that was about, and if you see here, this becomes 2-propanamine because we'll start numbering from here, but either ways amino group will be at number 2 position, right? So that is about the Iupac naming of it. Then we move on to the aldehydes and ketones. Aldehydes and ketones are very, very important. Why? Because you'll see that we'll talk about the aldehydes and ketones in the carbohydrates, the next chapter which we are starting after chapter 14, okay, we'll be talking about the aldehydes and ketones over there, right? And can anyone tell me what is common between aldehydes and ketones? Why we always write them together? Aldehydes and ketones. Why both of them are having similar properties? Because both of them have the, yes, carbonyl group. Absolutely. Absolutely. Because both of them have the carbonyl group, right? So that is why aldehydes and ketones have similar properties, because as you see here, both of them have this carbonyl group, right? Now, when we talk about the aldehydes, this carbonyl group is basically attached to at least one hydrogen, right? And what is the general formula? So it becomes RCHO, that is your aldehyde, okay? Now, formaldehyde. What is so special about formaldehyde? Formaldehyde is the only aldehyde which has, does anyone remember anything about aldehydes? Did you read it in chemistry? What is the formula for formaldehyde? Yes, it has carbonyl group, that's right. But how many hydrogens do we have in the formaldehyde? Two. Absolutely, right? In the other aldehydes, at least we have one hydrogen and then we have one carbon, right? So here, if you see, we have in the formaldehyde, if we have carbonyl group like this, okay, and then we have two hydrogens over here. So this is your C and this is your another hydrogen, right? So this, the common name is a formaldehyde. We also call it a methanol. Yara says, I just rejoined because when I raised my hand, I was talking. I could not hear. That's perfectly okay. That's okay. No problem. That's okay, Yara. Okay. Now we move on to the ketones. What about ketones? Ketones also have carbonyl group. As you can see here, they also have the carbonyl group. But here the carbonyl group is joined what? It's joined to two carbons. So this one carbon, this is another carbon. So here you will have two carbons over here. Okay. So what is the formula then for ketones? Ketones will become R, C, O, and R. That will be the formula of the ketones. Okay. So when it comes to the Iupac name of aldehydes, for example, we know that we replace the word E. Okay, we drop the word E and we use the word A, L for aldehydes. Okay. What do we use for the ketones? ONE, right? Yes, thank you. What do we use for ketones? We drop the last word E and we replace it with ONE. This is the ketones. And again, the same thing, the parent alkane will be always named first, right? We'll find out what is the longest hydrocarbon chain here, right? So once you identify the longest hydrocarbon chain, right? And especially the chain which contains the carbonyl group, right? And then you will start naming it. So this will become the propanol, right? And same thing with the acetones as well. Okay. So can we, let me give you one thing. So who will name this? 1, 2, 3, 4, 5, 6. Who will name this? Which compound is this? Are you sure it's Al? If it would have been Al, then the bond would have been at carbon number 1 if it would have been Al. No, 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 no. No, 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 no. Think once again. Mhm.
Can I try?
Yes, please go ahead. Tell me.
Is it a 3-hexone?
Mm, let me put this here. Now tell me. How will you name it?
I would say 5-methyl 3-hexone.
Very good. Yes, because I wanted you. I wanted you to make sure that from where will you start the numbering. That's what I wanted actually to know. Yeah, very good. Thank you.
You're
Yes,
welcome.
thank you. Yes, Rand. Rand, as I told you that, okay, this is just a revision thing. We're not doing any, this is all chemistry. We're not going to use all this in biochemistry. This is just the revision class, right? So as I told you that, yeah, so yeah, that one was, yes. Hello, can you hear me? Yes, the earlier one was 3-hexanone. Yes, you're right. But I wanted to give a methyl group here so that you compare the two. Yes. Yes, you need to know, absolutely, Rand. You need to know simply the functional groups. Just you need to identify the functional groups, absolutely. I'm more interested to start as I said that, if you remember, I told you yesterday itself, I'm really interested to start the real biochemistry. This is a revision class, right? You have read all these things in the chemistry in high school as well as in the chemistry. So if we will start teaching this the whole semester, at least at least we can teach this. If a chemistry person has to teach this, they will teach this at least for 2 weeks if we go with very slowly. So that is why this is just a revision class. So, but yes, once we start the biochemistry, we have to slow down. This is just a revision class. Okay, Ran? Okay, so see, let's practice these as well. Okay, so let's practice these as well. So if you see here, this is your which group? This is your aldehyde group, right? This will occupy always position number 1, right? So no need to name here, no need to give the number for the aldehyde group over here. So this will become what? This will become 4. If you start numbering from here, this will become 4-chloro-2,2-dimethyl pentanol, right? So because we have an aldehyde group over here, and this one, we have a ketone group this here at position number 3. So what will this become? This will become 6-bromo, and then this is the ethyl group over here, 4-ethyl, right? And then 3-heptanone. Okay, so that is it. That's how you will name this. Okay, now tell me something about carboxylic acids. Can you name any biomolecule which contains carboxylic acid? Yes, ladies. Yeah, there's a priority. You did not learn all this in chemistry. There's a priority basic. There's a priority list. Okay, at the end, I've placed that at the end. So this will tell you. This priority chart will tell you the shield about which one to give priority. This is at the end. Wait a minute. This one at the end. This one. So this will tell you about the priority. So you're going to give carboxylic acid priority over the esters, esters over the amide, amides over the nitriles. So you should know, and I'm sure that chemistry, you would have studied all this in chemistry, right? So you have to memorize this chart, right? You have to know this chart. Okay. Do you know something about fatty acids and the carboxylic acids? Did you study all this in chemistry? Yes, even yes, they also have COH group. Very good. Amino acids, absolutely. Yes. Okay. So once we will start fatty acids, we're going to talk about carboxylic acid again there. There itself, once we start discussing the biomolecules, right, we should be able to identify the functional group. That is very important. That is why this review presentation is there, right? You should be able to identify the functional group. If I say that this functional group is present in fatty acids, or this functional group is present in amino acids, so you should be able to identify this is a carboxylic acid. Okay, this is an aldehyde. If I say that aldehyde is present in sugars or ketones is present in sugars, then you should be in a position to identify, oh, this is a ketone, this is an aldehyde, this is a carboxylic acid, this is an amino group, right? That is basically the aim behind this review presentation, to identify the functional groups. I have been telling it from day one, right? Okay, so carboxylic acid is basically, again, they are the organic compounds which contain carbonyl group. As you can see here, they also have the carbonyl group over here, right? So once they have the carbonyl group, right, how can we write the carboxylic acids, right? Along with the carbonyl, they also have this OH, right? So we can simply write them as COOH, right? That's how we write the carboxyl group, right? This is the carbonyl group which is present here, and this is the hydroxyl group which is present here, right? You should be able to, that's okay, Ran, no problem. So you should be able to identify these two groups, right? This is the carbonyl and this is the hydroxyl group, okay? Now we know that lime juice which we eat, right, they contain the citric acid, right, which is nothing but the carboxylic acid. So the sour flavor which we get in the citrus fruits like oranges, right, that is basically because of the presence of the carboxylic acid. Okay, and then we're going to talk about the derivatives over here. Okay, we're going to talk about the esters, the acid chlorides, right? We're going to talk about all these things here. Okay. Okay. So what was your question? I'm sorry, I did not understand your question. Can you repeat that question? I did. Yara.
Miss, I didn't ask.
Okay. Okay, you didn't ask a question. Okay. Okay, so moving on further, when we say, yeah, the nomenclature of the carboxylic acids, right? So how are we going to name them, right? We are going to replace the E with the oic acid. So this will become ethanoic acid. This will become 2-hexanoic acid, right? So as you can see, the common name is acetic acid here, okay? And this is your 2-hexanoic acid. Why hexanoic acid? Because we also have a double bond over here. That is how you're going to name them, right? Now, when we talk about have you ever read about how these derivatives are formed in chemistry? And I'm sure that you would have. How do we basically how these derivatives are formed? I'm not going to, we're not going to do that now, but I'm just kind of asking you, do you know how esters are formed from carboxylic acids or amides or acid anhydrides? How water, the reactions? Do you all know the reactions? Like, you've read all this, right? In chemistry. Okay, I was just asking about that. Yeah. Now moving on to we're going to discuss about all these, but we'll move on to the nitriles first. Okay. So nitriles, as you can see here, you have to nitrile is very, very easy to identify, right? because if you see here, this will simply be RCN, right? That's how you'll identify the nitriles over here. Okay, and since it is sp hybridized, so you can easily identify, right, once it's present in a particular compound. Okay, so the carbon atom here in the nitriles is always assigned with the number 1. Okay, so that's why it becomes the ethane nitrile, right? We simply use the suffix nitrile here, right? In the acyclic nitriles, we are not doing cyclic nitriles over here, we're simply doing acyclic nitriles. We simply use the suffix nitriles here, okay? So that's why this will become the propene nitrile. So in Iupac name, you're going to use the word nitrile over here. Okay, nitriles are very, very important. I don't know whether you have heard about it or not. In medicine, I think you would have heard about the anti-cancer drugs like letrozole and the anastrozole. Have you heard about these drugs, ladies? No, never. Yeah. So basically, the drugs called as nitriles have a very important, they have an importance, especially against the breast cancer, right? Breast cancer in women, right? Whenever they have a tumor in the breast, which is especially an estrogen positive tumor, right? So at that time, the drugs, they contain the very important nitriles, as I said, that the letrozole and the anastrozole, right? This drug is so very important. It blocks the enzymes and does not cause the estrogen synthesis. So that is why it helps in inhibiting the tumor, a very, very important thing, okay, in the breast cancer. So as I said that here our interest is basically about biology. So that is why rather than discussing the chemical properties of any compound, it's very important we discuss how biologically those things are important to us, right? So that's why I brought nitriles over here. Okay, then you have esters. Okay, then we'll discuss about the esters. So esters, as we all know that whenever we talk about fruity smell, like smell in the bananas, pear, right? All the fruity smell, fruity aromas, that is basically because of the esters, right? They're known for their fragrances, right? And again, as they are the carboxylic acid derivatives, so they will have definitely a carbonyl group, right? Which is bonded, the carbonyl group is bonded to the OR group, okay? So you will have a carbonyl group, okay, which is bonded to the OR group, right? And when we talk about OR group, the R can be alkyl or it can be even the aryl. So it can be aromatic as well. Okay, not necessarily they can be always alkyl. Okay, so this is O, and then you might have this R could be either alkyl or it could be either aryl as well. So that is how we write the esters. Okay. So what is the general formula of the esters? How do we write esters? If you will get a compound, so if you see this group, right? So you should basically say that, oh, this is an ester, isn't it? RCOR is the ester. Absolutely, very good. So does anyone know how do we get these esters? What do we use to make these esters? The reactants for these, you might have heard about esterification. What do we use in esterification? Yes, absolutely. We use the carboxylic acid and the alcohol. Absolutely, very good, right? So that was about, and now once you have to, if you have to name the ester, the Iupac naming of the ester, so their name is basically derived from the carboxylic acids. Okay, so you will replace the word IC of the carboxylic acids, okay, with the word this OAT, right? That is why this will become methyl propanate, right? So similarly, this will become ethyl 2-butanate, right? So AT is the word, when you see this word ATE, so it should come in your mind that they are the esters. Okay, so then we have the carboxylic anhydrides. Okay, any question? Somehow I'm not able to see this. But that's okay. Okay, so anhydrides. So again, they are the derivatives of the carboxylic acids, these anhydrides. Okay, so we call them just the anhydrides, so sometimes we call them the carboxylic anhydrides. Okay, and we use, in the nomenclature, we use the word anhydride with the carboxylic anhydrides. Okay, so if you see here, we have the two carbonyl groups. If you see in a compound, you have two carbonyl groups which are bonded to same oxygen. Look at this, they're bonded to same oxygen, right? So you should get an idea that, oh, they are the carboxylic anhydrides. Okay, and I will not go into details that they could be symmetrical or asymmetrical or mixed. So we don't even want to know all that. We don't even want to know. We just need to identify the group over here, right? So simply, if you have a compound, like for example, if you have a compound like this, so as this is the line angle formula and this is the condensed structure. So once you see that, okay, we have two carbonyl groups, look at this, two carbonyl groups attached to the oxygen, that you should get an idea that they are they are the carboxylic anhydrides. So here this becomes pentanoic anhydride, as you can count the number of the carbon atoms over here. Okay, and this becomes ethanoic propanoic anhydride. Okay, so as I said, that you should be more worried about the identifying a particular functional group, as I have been repeating this on and off, right? So then we have the amides, right? Amides are also, we also use the suffix amide, okay, in the amides, okay. So they are also the derivatives of the carboxylic acid, okay, in which the amino group has replaced the hydroxyl group. So that means this amino group was never over here. There was a hydroxyl group over here, and that hydroxyl group was replaced with the amino group, and that is how we got an amide. Okay, so in short, you have to say the functional group of the amide is your carbonyl group, which is bonded to the nitrogen. So when you see something like this carbonyl group bonded to the nitrogen, right away you should get this thing in your mind that, oh, this is an amide. So why I'm telling you this, because you're going to identify the amino acids once we discuss the proteins. Okay, there if I ask you to identify the amide group, you should be able to know that, oh, this is an amide group. Okay, Dana, is this review with us in the midterm and the final? Dana, if you remember, I told you that yes, this review is there in the midterm and the final, but all you need to prepare is the Iupac name, which is the Iupac name of the hydrocarbons, and the identification of the functional groups. That is very important, Dana. Is it clear to everybody? Okay, so in the amide group, this is the suffix which I already spoke about. You can easily identify them by the suffix amide, right? In where we drop the OIC and use the word amide. Okay, so again the same thing. Then it can have an alkyl or the aryl group, but we'll not go into all those details. And nitriles, we already discussed about it. Okay, we're almost I thought of finishing this chapter within half an hour, but we took almost 1 hour and still we did not finish it, because I really wanted to start chapter number 14, because in chapter number 14, what is more important, because I know that because I've been teaching this course, so I know that teaching you how to give priorities is so very important. I need, because I teach them one by one in the classroom on the board, because we do give questions about how to set up the priorities, right? In that, So that is why I wanted to invest more time, because if you would have seen the syllabus in biochemistry, the syllabus in biochemistry is vast, right? If you remember, we have almost 12 chapters. Not almost, we have 12 chapters plus this review, right? So and chapters like chapter 14 is like, wherein, I teach one by one each and every compound how to set the priority. So I wanted, so this is something like, I know that, this you can do it, right? You have been doing all this in chemistry as well. But what you don't know, I wanted to invest more time on that. But that's okay. We are about to finish this now. Uh, so thiols, okay. So thiol, again, this is like a very easy thing to identify in a particular compound. You see the word SH. The moment you see the word SH, right, because it contains the SH group, and SH is called as the sulfhydryl group, right? And thiols, thiols, whenever anybody is working with thiols in a chemistry lab, oh my God, they have such an unpleasant smell. Oh, they have that fishy and a rotten egg smell. Okay. So that's how thiols are known for, right? And the smell which comes out of the sewage, that dirty smell, they smell like that. So that's how, thiols are known for. Okay. And so whenever we talk about thiols, okay, we always think about an animal called as a skunks. Do you know what a skunks are? Have you ever seen skunk? Isn't it? It looks like a cat, right? It looks like a cat. And do you know what they do? How do they protect themselves against the enemy? What do they have as a defensive mechanism? Yeah, the skunk spray, absolutely. Yeah, the spray is so very unpleasant, absolutely. And that spray contains these two thiols, right? So these two thiols are present in it's an American mammal, right? So they have basically glands present. They have a pair of glands present on each side of their, anus. And whenever they see an enemy, okay, they spray basically a kind of fluid, a liquid, okay, again, to protect themselves against the enemies, right? And that has a very, very unpleasant fishy smell. Okay. So that was about it. And then we have the last one is the acyl chloride. Excuse me. Acyl chloride, we also call it as an acid chloride as well. Excuse me. We also call them as the acid chlorides. Okay. And this is the functional group. They have, CO, Cl. This is a functional group which is present. Even the acyl chloride, I don't see any compound in the entire biochemistry where I encountered with the acyl chlorides. So that is how, and you have an alkyl or an acyl group over here. So our group will be over here. Okay. So these are the acyl chlorides. Okay. And this is the benzoyl chloride. Okay. So this is we call it an organochlorine compound. Okay. So it's like a very irritating liquid, this benzoyl chloride. You might have heard about benzoyl chloride being used in various pharmaceuticals as well as the perfumes. Okay. And these acyl chlorides, they are also derivatives of the carboxylic acid. So nothing much, just remember the group over here. That is very important. Okay, then we move on to the aromatic hydrocarbons, which are the benzene derivatives. Okay, so this class of compound, it can be represented by having what? By having a six-membered ring, okay, with an alternate single and the double bond over here, as you can see over here. Okay, a compound can have one benzene ring or it can have more than one benzene ring. Okay. And what is the formula, guys? What is the formula for benzene? C6H6. Absolutely. Absolutely. C6H6. Absolutely. Right. Absolutely. Kekule was the one who actually gave structure to the benzene, right? So these are the various derivatives, and I said that, as I said that, you know, there are excuse me. So as I said that, you know, even I didn't encounter anywhere benzene derivatives anywhere in the biochemistry. So kind of, you know what it is, right? So they can be substituted, right? For example, if you see here, the halogen substituted over here. Okay. So you're going to name them as a bromobenzene, fluorobenzene, chlorobenzene, right? Or here we have a nitro group. So nitrobenzenes. Okay. And then we have phenol. Phenol has a very important, significance in biology. What do we use phenols for? What significance do we have for phenols, guys?
Disinfectant.
Absolutely, antiseptic. Absolutely, right? Very good, right? So we have phenols, we have toluene as well, which is also called as, methyl benzene. If you see here, we have a methyl group here. Okay, so we also call it a methyl benzene. Okay, or as I said, we have the nitrobenzenes as well. Okay, and we have naphthalenes also. They also come in this category, right? The mothballs which we use, they also come in this category. Okay, so can we have benzene ring as a substituent, guys? Do you think we can have benzene ring as a substituent? Yes, absolutely. Very good. Super. Okay, so then we have, ortho positions. We might use, these positions, right? We might encounter these positions in biochemistry. So you should be knowing, and you definitely must be knowing about the ortho, meta, and the para positions, right? So ortho means when the substituent is, where's the substituent in the ortho position, guys? And the substituent is, yes, on adjacent carbons, then becomes ortho, right? And meta becomes when the substituent is on the non-adjacent positions, as you can see here, right? Very good. And then we have the para when we have on the opposite side, right? So I think that's all you should know. At least in this one, you should know about the ortho, meta, and para. Okay, that is it. So when you have more than one substituents, how do we name it? So you know that we'll use the alphabetical order to name this, right? It will become 4-bromo, 1-chloro, 2-fluorobenzene, right? And this will become 5-bromo, 2-methyl benzoic acid, right? Because of this over here. So that's okay. There's a lot of, okay, now, what is important is, yes, you should memorize this chart. Leave the no need to do this slide. No need to remember the pK values. You already might be knowing that lower the pK value, guys, what will happen if the pK value is lower? What happens if the pK value is lower? Lowest pK values are, what do you mean by that? If something is higher, the absolutely, right? pK tells you how stronger the acid is. Absolutely. Lower the pK value, stronger the acid is, right? That means your acid is completely dissociated in water. So in this chart, what do you think? Which one is the strongest acid? If I ask you this question, which one is stronger in this chart? Carboxylic acid, absolutely, right? With the pK value close to the 5, absolutely, right? So if we talk about pH, pH is the measure of the concentration of hydrogen ions, right? So you can just remember that in this chart, in this slide, you can just remember that what is the pK of the carboxylic acid. That is very important, right? So, and yeah, this one is important. If you have multiple groups, right, then how you should start numbering, right? So which one to be, which one should be given the priority. So you should, and I'm sure that you would have studied this in your chemistry as well, right? So this is the priority group. And with that, we finished the review chapter, and we're going to start with the new chapter because I really wanted to start new chapter, and I was very excited to start new chapter because, as I said, that is kind of a real biochemistry. No need to know, no need to memorize all of them. Just try to memorize the sorry. Thank you for letting me know. Okay, so what do you think? Our two hands, when we talk about our two hands, are they chiral? Are they identical? Okay, yes, your two hands are identical, but I am telling you that our two hands are identical in terms of connectivity. I know that in my right hand, I have 5 fingers. In my left hand, I have 5 fingers. In my right hand, I have a thumb. I have an index finger, long finger, middle finger, pinky finger. But just try to superimpose your right hand over the left hand now and tell me, what do you see? I want everyone to do it now. Take your right hand and try to superimpose it on your left hand and tell me, what do you see? What do you observe? What do you think? What happens? They don't match up. Very good. What about others? They're different. Why do you think they're different? Right now you said they're identical, right? Looks inverted. Very good. Okay. I want everybody to do this activity and tell me. They don't align perfectly. Very good. What else? They are mirror images of each other. Absolutely. That's what I wanted to hear. Even though you said that your two hands are identical, definitely they are identical, they have connectivity, but we will not call them identical, because when you try to superimpose your right hand over the left hand, what I can see that the thumb of my left hand is going on the left hand side, while as the thumb of my right hand is going on the left hand side. So they are non-superimposable. So can I say that my left hand and right hand is chiral? Can I say that my left hand and right hand, they are mirror images of each other? Can I say that they are mirror images of each other? Yes. Our left hand and right hand, they are non-superimposable images of each other, right? So anything which is a non-superimposable mirror image, right? We say that object is chiral, or that object shows handedness. But don't think that we are going to stop here. We are going to discuss chirality in this entire chapter. This is just an introduction. Now, if I ask you, how can we know whether a particular object, forget about compounds, I'll let you know how to find out a compound is in chiral or not. But if I ask you, how can we know whether a particular object is chiral or not? How can I say that? Yeah, enantiomers, we'll go back. That is my next topic, but I want to start with the chirality, Mohammed. Yes, we're going to talk about the enantiomers as well. Yes, you can draw a 3D object on a 2D paper, right? Or simply, if you want to tell me, if I ask you that whether this object is chiral or not, what will you do? You will simply examine that object, right? And you'll simply examine the mirror image of that object, right? And if they are non-superimposable mirror images of each other, or if they're asymmetrical, then we can say that the object is chiral. Okay. Have you ever tried, guys, when you, for example, stand in front of the mirror, what is happening in this picture? What do you see? What is happening in this picture? Can I superimpose these two pictures on each other? A man is standing in front of a mirror. Can I superimpose these two pictures? What do you think? No, absolutely not, right? If you look at this man is actually having left hand on the camera, right? But when you look into the mirror, it appears as if the man is having right hand in the camera. And no matter what, if I try to superimpose this man over its mirror image, I may not be able. Even if some things will be superimposed, but not everything will be superimposed. So we can say that this person is chiral, right? Then we have another word called as an achiral. What is achiral? That is an opposite of chiral. If I ask you what is the difference between a chiral and achiral, you will simply tell me, let me write down the word here so that you don't get. What is the meaning of the word achiral? They are two different words, achiral and chiral. When I say achiral, when I say this word achiral means that the object and its mirror image are identical. That means object and its mirror image are superimposable. Tell me about this. Gloves. Are they superimposable mirror images, gloves? Are they chiral or achiral, gloves?
Chiral.
Achiral, the chiral, absolutely right. If you try, no matter what you do, if you have a right hand gloves, you want to wear it in your left hand, no matter what you do, you cannot superimpose them because they're mirror images of each other. What do you think about this glass? Is it chiral or achiral?
Achiral.
It's achiral, because if you look at these two glasses, what happens? Both of them look similar, right? Both the glasses look similar. But if I will write something on this glass and then look into its mirror images, then can I say that it's still an achiral? Can I still call it achiral if I write something on this glass? Of course not, because that alphabet will be in mirror image in the glass, and then if something is written on this glass, we will say that it's chiral. But if nothing is written on this glass, we'll say that it is achiral. So chirality is basically when the two objects are what? They're non-superimposable images of each other. Right? What about this? This is also chiral. Look at the mirror images. They all look similar. They all look similar here, right? So that is basically chirality and achirality. But now you might be thinking, why are we studying chirality? Why is she teaching us this chirality? The reason for that is nature is chiral. Your body is chiral. The biomolecules which we're going to talk about in our body, like your amino acids, nucleotides, sugars, enzymes, they are all chiral in your body, right? So since inside your body, the biomolecules are chiral, so the things which we eat, the things which are created by the mankind, you will see at the end of the chapter, the drugs which we eat, even they have to be chiral. So the drugs, you will see that at the end of the chapter, we'll talk about that the drugs are also chiral, because inside our body, the molecules present inside our body, they show chirality. And why we are studying chirality, as I said that here, because in biochemistry, we need to know how things appear in three-dimensional structure. How do these biomolecules look like in a three-dimensional space? No matter you might be drawing a amino acid on a paper, that's a two-dimensional, but actually your biomolecule, like amino acid, is basically, you have to view it in a three-dimensional structure. And we call this as a stereochemistry. Stereochemistry is a discipline of chemistry where we study the arrangement of the atoms in the space. Right? And thanks to your tetrahedral carbon, which gives us stereochemistry. That was just an introduction of the chapter. We will we'll continue next week. So next week, whole week, we'll be talking about this chapter. Okay. So I have to log into my next class. I didn't even realize time is up. Thank you for staying back. Any questions?